Hello everyone, my name is Raina Dejude and welcome to my Module 12 Concepts video. In this video, we will be walking through 3 concepts that I experienced either for the first time or on a deeper level this week. Those 3 concepts are DTOs, layered architecture, and global exception handling. So let's dive in. So the first concept is DTOs. What is DTO? DTO stands for Data Transfer Object, and DTOs are plain Java objects that act as messengers between your API and your business logic. They're separate from your database entities, and that separation is intentional. So let me show you why this matters in our project. If we take a look, we can see we have a modals folder. And these are JPA entities. So we've got things like address, courier, customer, employee, etc. These are tightly linked to the database with relationships like one-to-many or many-to-one. If we expose these directly as API responses, we hit a critical problem, which is infinite JSON recursion. For example, the order entity has a one-to-many relationship with product order. If a client requests an order and we serialize the entire entity, the JSON would include all the product order objects, which would include their parent order, which includes product order again, and again, and again, and again, and that is the infinite recursion. So that's where our DTOs come in. In the DTOs folder, we have classes like API Courier Status DTO, API Courier DTO, etc., etc. These are plain objects with no JPA annotations, no relationships. They only expose what the client needs. An API order DTO might have an ID, a customer ID, and a status, but not the entire nested graph. And we also get our validation for free. Our DTOs use Jakarta validation annotations, which is the @not-null or @not-blank. When a client sends a request to API orders, the controller validates the incoming DTO with @valid. If validation fails, then the request is rejected before it even touches the service layer. This is a clean separation of concerns. And here's the real benefit. Your database schema can change without breaking your API contract. So if tomorrow we refactor how addresses are stored, the API response stays the same because it's controlled by the DTO and not the entity. The mapping happens in the service layer through private methods that extract fields and handle null checks. DTOs also provide security, so entities can expose internal structure or relationships that expose too much. DTOs are your controlled API contract. So if we move on to concept number 2, which is layered architecture, controller, service, repository. We follow a 3-tier architecture, and every request flows through it the same way. Controller, then service, then repository. So let's break down each layer, starting with controller. The controller layer sits in controller API controllers like order API controller, status API controller, etc. Our controllers are thin and focused, so they accept HTTP requests, validate the incoming DTO using the @valid annotation, and immediately hand off the work to a service. Controllers don't contain business logic, they're just orchestrators. So if validation fails, the global exception handler catches it and returns a consistent error response, which we'll cover next. The service layer lives in service. This is where the real work happens. So order service, address service, product service, these contain all of the business logic. They orchestrate repository calls, enforce business rules, manage transactions, and handle entity to DTO mapping. For example, when you create an order, the service might validate that the customer exists, that the restaurant has products, enforce business constraints, and then call the repository to persist the data. The service layer is responsible for the how. So how do we create an order? How do we check all of the orders? The repository layer is inside of the repository folder. So these are the database access objects extending the JPA repository. Spring Data JPA gives us built-in CRUD operations for free, so create, read, update, and delete. For more complex queries, repositories can include custom native SQL. So in this project, we use repositories for things like querying all orders by customer or finding restaurants by rating. So here is the total flow. An HTTP request comes in, the controller validates the DTO, calls the service, then the service applies business logic and calls the repository queries the database, and then the response flows back up. This separation makes the code testable, maintainable, and scalable. Now, the million-dollar question, why does any of this matter? If you need to change how you fetch data from a database, you only touch the repository. If you change the business logic, you only have to touch service. The controller stays the same. It's a clean contract between all of the layers. And then we can move on to concept number 3, which is our global exception handling. So instead of scattering error handling throughout every controller, we use a centralized exception handler. So inside of this exceptions folder, we have a class called API Exception Handler. This is annotated with the REST controller advice, which means it intercepts exceptions thrown by any controller inside of this application. We've also annotated it with ordered highest precedence to ensure that our custom handler takes precedence over Spring Boot's default error handler. This gives us full control over all of the error responses. Here's what we handle. So we have bad request exception, resource not found exception, validation exception, method argument not valid, illegal arguments, data access exceptions, constraint violation exception, and then a catch-all for anything that's unexpected. So every single one of these returns the same standardized response format, which is an API error DTO, as we can see right here inside of these arrows, with an error type and with details. This is powerful and useful because clients know exactly what to expect. If they send invalid data to API/orders, they get a consistent error response. If they request a non-existent address from API addresses by ID, they get the same response format. So there's no surprises and no inconsistency. This also allows us to use the dry method, which is don't repeat yourself. If everything calls on the same global exception handler, and we don't have to clutter our service and controller code with try-catch blocks all over the place. We throw domain-specific exceptions, and the global handler converts them into appropriate HTTP status codes and response bodies. It's very clean and very centralized. So to recap, we use DTOs to separate API contracts from database entities, keeping our API stable and secure. We structure the application in 3 layers, so controller, service, and repository, so each layer has a single job, and we use global exception handling to give clients predictable error messages from anywhere inside of the application. These 3 patterns work together to make RocketFood delivery maintainable, testable, and ready to scale. So that's all I have for this video. Thank you for watching, and I will see you on the next one.